You need to be able to take a set of coordinates and decide, is it even a parallelogram? If it's a parallelogram, is it a special parallelogram? Is it a rectangle? Is it a rhombus? Is it a square? Okay. There are 3 different methods that you can choose. What you can do is you can use the distance formula 6 times. Okay? Now, if I find the length of all 4 sides, how do I know if it's a parallelogram? Hayden. Okay. So, well, let's just talk about a parallelogram.
Oh, opposite sides are equal?
Okay. We would have opposite sides congruent, right? So if we find all 4 sides and each pair of opposite are congruent, we know we have a parallelogram. Okay? What would we look for in a rectangle? We would find the 2 diagonals, and what would that tell us? If
they're equal.
Okay, if our diagonals are congruent, then we know it's a rectangle. Okay. Of the 6 things we find, what would give the rhombus away?
They're all equal.
Okay. If all 4 sides are equal, we know that it's a rhombus. Okay. Now, how do we classify a square? Okay, if it's a rectangle and a rhombus, then it's a square. Okay. Okay, so if all of those things are true, we have a square. Okay. Okay, now some of you are like, distance formula, that stinks. Okay, we don't have to do that. We could do the slope formula 6 times. Rise over run. If it's on the coordinate plane. If there's not a coordinate plane. Okay. Okay, so I'm hearing, what's the slope formula?
Rise over run. What's the distance?
Okay, so if we find the slopes of the 4 sides, in order to be a parallelogram, what has to be true? Okay, our opposite sides need to be parallel, which means we need to have the same slope for one set of opposite sides and the same slope for another set of opposite sides. Okay? Now, if it's a rectangle, and we're talking about slopes, what are we going to look for? Micah? Yep. Yes, our consecutive sides need to be perpendicular because a rectangle has 90-degree angles. Okay, in terms of slope, what would we be looking at with a rhombus? We know that the sides are congruent, but slope's not going to help us with the sides. Yes, in a rhombus, our diagonals are perpendicular. And then, of course, if it's a square, all of those things are going to be true. Okay, now your third option is to look at only the diagonals. Okay? We have three things that we can calculate by just using the diagonals, okay? So if it's a parallelogram, one of the first things we talked about is that the diagonals bisect each other. So what would you have to find? I know, how would you do that? What are you finding? Nope, not slope. Nope. Midpoint. Okay. If it's a rectangle, what is true about the diagonals? The diagonals are congruent, so you can use the distance formula on your diagonals. Okay, so the midpoint's going to tell you, yes, it's a parallelogram. The distance is going to tell you, do we have congruent diagonals or not? And then what about a rhombus? What's true about the diagonals? Diagonals are perpendicular, so you would find the slope. Okay. All right, so I am going to be specific with each of these examples. I am going to tell you the method that we're going to use. In your worksheet, 3 of the problems I'm going to tell you the method you need to use, 3 of them you get to pick. Okay, so in this first one, we are going to do the distance formula. Okay, now as you're plotting these, you can make a guess. What do you think we're going to get?
Rectangle.
Okay, so if you think we're going to get a rectangle, then we know that the opposite sides need to be congruent. And when we find the diagonals, hopefully the diagonals are congruent. Okay, now, all right. So first we need to make sure that AB and CD have the same distance. Okay. So if I'm using A and B, I'm going to take 8 minus 9 squared and -2 minus -4 squared. What do we get? Square root of what? This would give us 1 squared, right?
3.
This would give us 1, and this would give us 2 squared. So square root of 5. Okay. Okay, so now let's make sure CD is the same. CD, we're going to take 3 minus 2 squared and -7 plus 5 squared. So it's -7 minus -5. I'm sorry. Is that square root of 5?
Yes.
Okay, good. Okay, now we better check the other set of opposite sides. BC, we need to find the distance, and AD. Well, let's make sure. BC, we have 2 minus 8 squared and -5 minus -2 squared. I disagree with the square root of 37. BC, 2 minus 8. Okay. So wouldn't this be 36 plus 4? Right? 36 plus 4? 9. That's what I meant.
45.
Yeah.
No. You got it wrong.
What?
I think you got it wrong. I never did.
That's like -3, so -3 should be squared.
Yeah. Do you get it?
Okay.
I should have
Can you fix my mistake there? Okay. You want to maybe write it on there? All right. So then AD, we have 3 minus 9 squared and -7 minus -4 squared.
$45.
Woohoo! Okay, so what do we know? We know that opposite sides are congruent, so we at least have a parallelogram, but it is not we don't know that yet. It is not a rhombus. What would be true if it was a rhombus?
Both sides would be the same.
All 4 of those would be the same. All right, so now let's talk about our diagonals, AC and BD. What? If we want this to be a rectangle, we are hoping that these are the same.
That's a lot of distance.
Which is why you get to make a decision eventually. So we have 2 minus 9 squared and -5 minus -4 squared. Square root of 50. Okay. For BD, we have 3 minus 8 squared and -7 minus -2 squared. Okay, so we have opposite sides that are congruent, but not all 4 congruent. We have diagonals congruent, so we have a rectangle. Okay, now, if you choose to use the distance formula, I better see all 6 of those. Okay, let's look at what happens when we use, yeah.
Actually, it's not 52.
Oh my God.
20. Oops. Thank you, Alex. All right. So here we go. We have -2, -7, 1, -5, 4, -7, and 1, -9. We're going to use slope. Okay, so some of you are getting an inkling. I think we're getting a rhombus. Okay?
That's not what I got.
I'm on the bottom one.
Well, you don't have to erase it.
Oh, you're
We're
right.
still going to do that one. All right, so
No, okay, I did it wrong.
we need to find the slope of opposite sides. So AB and CD. Hey, if you have a graph and you want to count rise over run, that's totally cool.
Wait, I should still be right.
Wait, actually. Thank you. Okay, rise over run. What do we have for AB? Yeah. What is it? 2, 3. That's not a slope. Thank you. 2 over 3. Okay. When you count the slope for CD. 2 over 3? Okay. If we count the slope for BC,
Negative 2 over 3.
negative 2 over 3. And AD?
Negative 2 over 3.
Okay. So I see that opposite sides are parallel because we have matching slopes. Are opposite sides perpendicular? No. These are not opposite reciprocals.
What's opposite?
But if it
Was
was
that like
if it was
3 over
negative-
2? Yeah, okay.
If this was negative 3 over 2, then we would have 90-degree angles and we know it's a rectangle. Okay. Now, we got to check the diagonals. Okay. Oh my gosh. What is the slope of AC?
90.
Zero?
0. I didn't say that.
What's the slope of BD?
0.
What?
Isn't it 1?
No.
It's undefined.
So,
So our diagonals are perpendicular. They're opposite reciprocals. So what is it? It's a rhombus.
Wow. How do you say that? It's a rhombus. Austin, we can tell by looking at you that you're a rhombus.
Okay. It's a weird diss.
He's pretty angry.
Okay, last one.
I think you tell that you're a rhombus. Alright, square.
wait, I think I can guess what the next one is.
What do you think?
Square.
We have some inklings that this could be a square. Okay. I want to use the diagonals only method on this one. What? This is actually not bad at all. Okay? Okay, so let's find the midpoint of AC and BD. Okay? So if we find the midpoint of AC, we're going to add the x's, divide by 2. We're going to add the x's, divide by 2. So negative 1, comma, negative 5. Okay? BD, add the x's, divide by 2. Add the y's, divide by 2. Do we get the same midpoint?
Yes.
Okay, so our diagonals bisect each other. We know it's at least a parallelogram. All right? Let's just get the distance out of the way. No. So AC and BD. So the distance between A and C $52. BD, 1 minus negative 3, and negative 2 minus negative 8. So our diagonals are congruent. Now we need to do slope. Okay, the slope for AC. -4/6, right? If we go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, okay, which is -2/3. And then our slope for BD, 1, 2, 3, 4, 5, 6. Oh. Are our diagonals perpendicular?
Yes.
What do we got? Oh, we were right.
A parallelogram. Wait, on the test, is it going to show the diagram, or is it just going to give you the angles?
On the test, I think you'll have one with a graph and one without.
Can we use whatever theorem we want, or do we have to use a specific theorem?
You will get to use